Hi, I thought I would tape a video today on how to graph a standard form quadratic and to put that quadratic into vertex form. So I'm starting out with a quadratic equation here, and the first thing, if I'm going to graph this on a grid, on a coordinate plane, then I need to find the vertex. So the first thing I'm going to do is I'm going to use the formula to find the vertex. And this was talked about and given in class. So to find the x value of the vertex, which is h, so the vertex is going to be in the form of hk. So to find h, I would say negative b over 2a. So in this case, b is positive 6, so the opposite of positive 6 is negative 6. Multiply times 2 times negative 3. And so it's negative 6 over negative 6, so that would be a positive 1. So once I have my h value, I can plug my x value into my original quadratic equation. So in this case, it becomes y is equal to negative 3 times 1 squared plus 6 times 1 minus 1. And so it's going to be negative 3 plus 6 minus 1. And that final answer is going to be negative 2. So my k value is negative 2. Now, if I was going to graph it, I'm going to also need to solve for what my x-intercepts are. Now, from the standard form equation, my c value is my y-intercept. So my y-intercept here is 0, c. So in this case, it's going to be 0, negative 1. So automatically, I can graph some things. Now, I know it's going to go in the downward direction because a is negative 3. I know it's going to be fairly narrow because it is a whole number and it's greater than 1. And the y-intercept is negative 1. So let's start looking at our graph, and I'm just going to make a grid on some graph paper. And my vertex, we said, was 1, negative 2. So that would be my vertex. And then it says my y-intercept is 0, negative 1. So in this case, I have to think, well, am I doing something that's not right? So let's go back and look at our original problem and just make sure that we have done everything correctly. So my original, I have the opposite of b over 2 times negative 3, so that is going to be 1. So then when I plug this into the equation, I'm going to have negative 3 plus 6 is going to be positive 3, minus 1 is going to be positive 2. So I knew something was incorrect. So my vertex is not going to be 1, negative 2, it's going to be 1, positive 2. So that's how you kind of make sure that you are getting it the right way. And the reason I knew that is because my y-intercept is going to be 0, negative 1. If my vertex was down here, there's no way that if it's going to be in the downward direction that it's going to hit the y-axis at negative 1. So that's why it's so important not to trust your graphs on your calculator so much, and you need to know what you're doing. So in this case, I'm going to have an axis of symmetry, and that axis of symmetry is going to be at x is equal to 1. So it's my h value. So I have an axis of symmetry right here. And what that tells me, it allows me to get this point over there. Because if this is 1 to the left of my axis of symmetry, I know that the next point is going to be 1 to the right. So now if I want to find out what my values of x are when it hits the x-axis, I can use the quadratic formula. I could also use the x factor, but I know it's not going to work in this case because it's going to be some fraction number. So let's just go ahead and use the quadratic formula, which is x is equal to negative b plus or minus b squared minus 4ac over 2a. So in this case, I'm going to plug in 6 for b plus or minus, and so that's going to be 36 minus 4 times negative 3 times negative 1 divided by 2 times negative 3. And I just continue to simplify here. So it's negative 6 plus or minus, and that's going to be 36 minus 12. So it's going to be 24 over negative 6. And I don't even have to simplify this because I want the decimal form. So I'm going to plug this into my calculator. My first value is going to be negative 6 plus the square root of 24 divided by negative 6. So my first value of x is going to be 0.18. And then my next value of x is going to be negative 6 minus the square root of 24. And let's see what that is equal to, divided by negative 6. So then I have x is equal to 1.82. So on my graph, this is going to be where it hits the x-axis. So I'm going to graph there, which is going to be a little bit closer, and then here, and then I can go ahead and make my parabola. Okay, so that's how I graph it. Now I want to go ahead and I want to turn this into a vertex form equation. So I've got some information that's going to help me do this. And that information is my vertex, and that information is my a value that came from my standard form of my equation. So the vertex form of a quadratic is y is equal to a times x minus h squared plus k. And so that's y is equal to, and a is still negative 3 from my original standard form equation, x and the opposite of h, so it's going to be minus 1 squared, and then plus 2. And so this would be my vertex form of this same standard equation. Now, a couple of things that we added to our situation is looking at the graph. We need to be able to describe some characteristics about the graph. And I'm going to go ahead and label this 1, 2 as my vertex. So the few things that we can determine from our graph is range. And I'm going to put domain up there because usually you hear about domain before range. And domain, remember, is what x values do I have a graph for? And here I have a graph for every single x value. I can plug in negative 1,000 into my original equation and I will come up with some y value. So that's going to be all real numbers, or you can write it like from negative infinity to positive infinity. Okay? Now my range is where I have some restrictions, and this is, you can write it two different ways, and either way is correct. And here my y value is going to be less than or equal to 2, because I don't have a graph of any number above 2, so it has to always be less than or equal to 2. Now I also can write this as negative infinity to 2. Okay? This is not a point, this is an interval on the graph. Now, the next thing that we can talk about is that the graph is increasing, and this is increasing, and you're reading the graph from left to right. So what is my graph doing from left to right? And as I'm going from left to right, it is increasing from negative infinity all the way till x is equal to 1. Okay? And then decreasing when it hits that vertex at 1, it's decreasing all the way from 1 to the positive, and when x is positive infinity. The next thing that we talked about is end behavior. And end behavior is just looking at my arrows and where they're pointing. You're going to tell me what's happening to my graph as x approaches negative infinity. You're telling me that f of x, or my graph, so as x goes this way, y goes to negative infinity. And as x goes to positive infinity, here, y goes to negative infinity, because it's going down. So I'm looking at the end and where it's going. Whereas when I was doing my increasing and decreasing intervals, I'm reading the graph from left to right, and I'm describing it. So hopefully that will help you with the standard form.